This Lunch and Learn, I'm going to tell you about Reason. So one thing I like to do is every now and then I like to learn a new programming language. Because every time I do that, I learn a lot. And I think every language has its own concepts, its own unique concepts, and its own take on things. And I think you just become a better programmer by learning programming languages, because it provides you with new insights and with more perspectives. And for the past couple of months, I've been learning Reason. And Reason is a programming language. It's a statically typed language. It's a functional language. I've put here mostly functional because you can write very functional style code in Reason, but it also has a full object-oriented system. I don't think it's used that much. I haven't used it, but it's there. It's a pretty new language still. It was first released in 2016, and it's created by Jordan Walke, who is also the original creator of React. And there's this story that Jordan shared on the Reason podcast, which was quite interesting, I think. And it's that when he was originally designing React, his vision was that all React code should be written in a functional programming language with a static type system. So the initial prototypes of React were actually written in standard ML. But eventually they had to drop standard ML because he couldn't get the React API, as we all know it, to work in standard ML in a way that's convenient for developers. So they decided to ditch standard ML and instead write React in JavaScript. And basically Reason is the second take to deliver on that original vision that React code should be written in a functional language with a static type system. So basically Reason was created to deliver on that vision. I think by now the goal is much more ambitious, so it's not only to write React applications, but I'll talk more about that later. So I just told you that it's a programming language, and you can look at it that way, but actually it's not an entirely new language, but instead it's a new syntax and toolchain for OCaml. And OCaml is a much older programming language that was first released in 1996. So Reason builds on top of OCaml. And the way it works is Reason uses a buckle script. And buckle script is a project that has existed before Reason existed. And buckle script is basically a compiler of a fork of the OCaml compiler that can output JavaScript and can interpret Reason code going in and JavaScript code going out. And buckle script is actually on a quite old OCaml version now. It's OCaml 4.02, which I think was released in 2015, so that's quite old. But they are working on upgrading buckle script to use a newer OCaml version, I think 4.06. What I haven't told yet is that Reason, so Jordan Walke, the creator of Reason, works at Facebook. So Reason is mostly a Facebook project now. I think there are some external contributors as well, but I think the main development is sponsored by Facebook. And like I said, buckle script was an existing project, so that's not from Facebook, but Facebook contributed Reason support to buckle script. So I think there are still other people working on buckle script, and Facebook also contributes to buckle script in general and also for specifically the Reason support. And also you can compile Reason to both JavaScript but also to native code. So by default, OCaml compiles to native code, and via buckle script you can also compile Reason to native code. Right, so using Reason, you can use Reason in many different ways. It's often used together with Reason React, and Reason React are basically Reason bindings to React.js. So if you're using Reason React, you're really just using React, but with a type system on top of it. So Reason React is a very thin API layer around regular React. And it just makes working with React in Reason convenient and type safe. So that's one option. I think it's pretty popular, but it's not the only option. There's also buckle script T, which stands for the Elm architecture. This is exactly what it sounds like. So if you use this library, then the code looks almost identical to Elm. It's almost the same API, and you can work in the exact same way as Elm, but using Reason as your language. And in general, you can use Reason wherever you would use JavaScript because it compiles to JavaScript. There's nothing really special. You can use it in the front end, but you can also use it in Node.js. I think it's mostly used for front end currently. And the back end, some people are using Reason together with Node.js, but I think a more popular option for the back end is to compile to native code and then use the OCaml ecosystem. But the native story for Reason is still quite young. So in general, Reason is quite young, but the native compilation to native is really, really young. So that's, yeah, I think it works, but the ecosystem is not that big yet. So yeah, but perhaps in the future it will become more popular. Yeah, something else that's, I think, very important is that the interoperability with JavaScript is quite good. You can bind to JavaScript APIs. I have an example about that in a minute. So you don't have to rewrite all your code in Reason. You can just keep using JavaScript libraries or even custom JavaScript code you wrote. And you just can write bindings to it where you specify, hey, I have this function in JavaScript. And you can call it this way. The return type is this, and the arguments are these and these types. And that works really well. There are a lot of, on NPM, there are a lot of packages that do just this. And basically, Reason React is also such a library that just has bindings to an existing JavaScript project. And with Reason React, it's even very easy to reuse React components. So for React components, you can actually bind to the React component itself. So you can write a very thin wrapper around the JavaScript React component, where you only need to specify what kind of types the props have. And then you can just use the JavaScript component. So by now, you're probably wondering what Reason looks like. So I have a few examples here. This is a definition of a simple function called greet that takes a name argument and returns a string that says hello and the name concatenated. You might notice that I haven't written any type declarations, but still this function is fully typed. And that's because OCaml has really good type inference. So you don't have to write any type annotation almost at all. But it is recommended in public functions to always write the type annotations explicitly. But yeah, the OCaml is really, really good at type inference.
What is that?
Type inference means that OCaml can see that because you're concatenating name to a string, it means that name must be a string. So it knows that the argument must be a string. And also it sees that the return value is always a string. So it can just infer that the type of this function is a function that takes a string and returns a string. And this is actually the same functions, but then with explicit type annotations. So here I did say that name is a string and that the return value is also a string. And like I said, if you're writing public function, it's always recommended to do write the type annotations. One, for documentation, but two, also if you rely on the type inference, then sometimes strange things might happen, because if you suddenly in any case, if you use type inference, then sometimes you can get surprises, because then if you use a different function, then suddenly your function returns a different type, and it's very difficult to see what's happening. So I tend to always write the type definitions unless I have really small functions that do something very similar, very simple like this. Then this is also mostly the same function, but this uses named arguments. So if you prefix an argument with a tilde, it becomes a named argument, and then you call it like this. So you call the function name, the name of the argument, and then the value. And if you have multiple arguments, then the order doesn't matter either. So you can, if you would have a second argument, you can swap the order of the arguments. I think it's really nice because it's a really simple way to have named arguments, and that way you can make your functions much more explicit. Currying, so Reason also supports currying in a very easy way. So this is a function add, which has two arguments, And by just calling the function, but only applying one argument, you can create a new function. So here I called the add function, but I only passed one argument. So if I then call this function, I only need to pass the argument that was missing still. So this function add 5 becomes a function with one argument, and it will always add the 5 to it. That's something you can also do in JavaScript, but in JavaScript you have to sort of manually write the currying, and then Reason does it automatically for you. And this is also, again, fully type safe. So the type of this function is a function that takes 2 integers and returns an integer. And the type of this function will be a function that takes 1 integer and returns another integer.
Is number a function of an integer?
Sorry?
Number in the last line. Is it a function?
Oh no, so this is the actual result indeed. So the number here is 10. Yes.
The type is integer.
Yeah, yes. So this is a record. A record is like a struct or an object. In this case, it's a person type, which has an age, that's an integer, and a name, which is a string. And this is how you would create such an instance. So that's me. I'm 29. My name is Pascal. And that's how you would instantiate such a record. And this is the update syntax. So by default, everything in Reason is immutable. So lists are immutable, records are immutable. So if you want to update something, you can use this syntax. And it's very much inspired by JavaScript. So this is the object spread syntax from JavaScript, where you can say, okay, I'm going to create a new version of this record. You need to copy all the properties from the old version, so from this variable, and you need to update, in this case, the age.
I have a question about the second line. If you leave out person and say you have another structure which also has an age and a name, what would it do then?
Yeah, that's interesting because Reason uses the field names and types for type inference. So if you would have another record definition in scope that would have the same names and types, I think you would get a compile error because it cannot do the type inference because it doesn't know what it is. If you have another type, which for example only has an age, then it can automatically infer that it's this other type.
Yeah, okay.
But so it works based on the names of the fields and the types of the fields. So even for records, you oftentimes don't have to write the type definitions. But again, it's recommended to do that. For example, in the project I used to learn Reason, I had 2 records that were very similar. So the one was a note and the other one was a notebook. And they shared, I think, almost all fields except for one. And then sometimes the compiler could really get confused. So if you would then use the fields that are shared across both types, then sometimes it would infer the incorrect type. And then you get strange type errors, which you can always solve by explicitly writing the type definitions. So that's another reason to write the definitions. So this is a bit bigger example. Here I've created a sum type, which is sort of like an enum in Java, if you know Java. And here you can say, so these are like constants, so you can be a teacher or a director or a student. And in this case, the student also has a name. And the other variants, they could also have their own properties. Doesn't have to be one either. So for example, the teacher could have 2 fields inside it. Then this is how you create such instances. So person 1 is a student with my name, and person 2 is a director. And then here I have a function that takes a person and then writes out a greeting. And this uses pattern matching. So here I'm pattern matching on the person, and the compiler will enforce that you handle all possible variants. So in this case, there are 3 variants. If I would leave out director, that would be a compile error because I haven't handled all the different variants. And this is really powerful because you can pattern match on anything. You can pattern match on these variants. You can pattern match on a person with age smaller than, 20 or something like that. And you can also use pattern matching to unpack whatever you're pattern matching on. So in this case here, I'm unpacking the string that's contained in the student, the name of the student, and I can then immediately use that field. And in the same way, you can parent match on lists. So take out the first element of the list, and leave out the rest, or whatever you want. It's really, really powerful. Also, what's nice to see is the JavaScript code that it's compiled to. So the JavaScript code that Reason produces is pretty readable. And as you can see, in this case, the student is represented as an array with one item. And you don't really want to rely on that fact, because it is just some optimized representation that BuckleScript chooses to represent your typed code. But still, if you look at this is quite readable. Could be something that you would write yourself. Just interesting to have a look at. And in general, Reason produces very efficient JavaScript. So, for example, if you see over here the director, it's not really anything. It's just something that needs to be identified uniquely. In this case, it just picks the integer 1 to identify it. And I think it does the same, for example, for empty list. An empty list is, I think, represented as nil or something like that. So there's a lot of very optimized representations of the concepts that live in Reason. So then I have a few examples on Reason React. So if you're writing React code with Reason, this is what it looks like. Basically, you have a few kinds of components in Reason React. So this is a stateless component, which is very similar to a functional component in JavaScript. And the way it works is you need to define the component, and then you need to create a make function, which is basically invoked when you write JSX. So you can embed JSX in Reason, and when you embed JSX, it will just use the name of the module and invoke the make function to actually produce the React component. And then every prop will just be a labeled function argument. So in this case, this component is a greeting component. I don't know if I have no, I don't have an example how you use it. But so this is a greeting component that has one prop named name. And I haven't specified the type here, but it's a string. So there's one prop called name, and it's a string. And you would use it just as you would use it in JavaScript. So it's just the greeting component name is, and then some string. And as you can see, it's just regular functions, really. And Reason React also passes you the children, if there are any. So you don't need to get them from the props, but you get them separately. I have another example, which is a bit bigger. So this is a Reason component with state. So Reason React sort of has a Redux-like mechanism built in, so there's no set state like you have in JavaScript, but instead you have reducer components. And the way it works is you define your state. So in this case, state can be anything, right? So it can be a record that says, okay, I have a name and an age, for example. It can be anything. And in this case, I just have a simple integer as my state. So I define type state as an integer. Then I can define the actions that I want to mutate the state. So in this case, I can increment or decrement my integer. Then you define a reducer component. So instead of calling it a stateless component, you call it a reducer component. And the reducer component is very similar to the stateless component, except that you need to pass a few additional options. For example, what's the initial state? And in this case, it's an integer, initial state is 0. And you also need to pass a reducer. And the reducer is a function, just like in Redux, that takes the action and takes the current state. And then you can parent match on the action and return a new state. So this is very much like Redux. So here I'm returning the new state. And in this case, I wrapped it in Reason React Update. There are also a few other variants. For example, in some cases, you don't want anything to happen when a new action comes in. And then you would return Reason React No Update. And that's a little bit of noise, but it's needed to make everything type safe, and it can only return one type, so you can't return an integer here and in another case return something else, so it needs to be all of the same type. So this is then the JSX that you render, and here you can just use again the state using self.state. The name of the field, or in this case state is an integer, so self.state is just an integer. And here you can see how you can dispatch actions. So increment and decrement are the only possible actions. And for example here, if I click this button to increment the number, I just call self.send, and I'm sending this increment message, which will trigger something in Reason React, which will then call your reducer, and then the state will change, and your component will be rendered. So in this, these are two examples of where Reason React is a little bit noisy because it needs to be type safe. And JSX is also type safe in Reason. So you cannot just put a string inside of JSX because then a string is not a React element, and everything needs to be a React element. So you need to wrap your strings in Reason React.string. That's a bit ugly, but yeah, that's what it is. There's a new version coming out of Reason React soon, and there they are trying to cut down the overhead a little bit. So in the future, Reason React functional components will look something like this, where you just have one function which can take labeled arguments as props and has this React component annotation. So they are working to reduce that noise a little bit. So that's something that's coming. Now, so here I do have an example of how you would actually use such a Reason component. And here I just wanted to show you the type safety and the experience you get as a developer when working with Reason React. So here I have that greeting component again. And then I can just use it in JSX. But in this case, I haven't passed the name property, the name prop. So then you just actually get a compile error that says, hey, this call is missing an argument of type string, and it's supposed to be the name. So that's really, I think, the biggest benefit of writing React in Reason, is that you get all this nice type safety. So it works for your own components, but it also works for HTML components. So in this case, I've written the anchor tag, and as the href, I specify the 0 instead of a string, and then I also get a type error that it should be a string instead of an integer. So it's really nice to get that feedback from the compiler. Yeah, so like I mentioned, there's very good JavaScript interoperability. So you can write type definitions for existing functions in JavaScript. And in this example is how you would write a binding for set timeout and clear timeout, which are global functions in JavaScript. And so what you do is you use the external keyword and you give it a name. And then you specify the types of that JavaScript function. So set timeout takes a function that has one argument of unit, which is basically nothing, and it returns unit. It doesn't really return anything. It doesn't matter. And the second argument is an integer, which in set timeout is how long the timeout should take. And then what you get back is a timer ID. And we don't really know what a timer ID is, and it doesn't really matter either. So we just define that we have a type of timer ID. We don't know what it is. We only know that the only way to get a timer ID is by calling set timeout. Then the next definition is clear timeout, which takes such a timer ID and returns nothing. And this is very powerful because now the compiler knows that if we're calling clear timeout, you should have a timer ID. And the only way to get a timer ID is by having called set timeout or set interval. But see, that's really powerful. So just by writing these type declarations, you get all this type safety for something that was not originally written in Reason. And this is a very basic example. You can do more complex things, like you can bind to import a JavaScript module. So then you would write a few additional annotations that will import a module, and then you can bind to the default export or to another export. So this is quite quite easy to do. I think the first time I saw this, I didn't really understand what was going on, but if you've written a few of these bindings, then it's really simple to write them. Oh yeah, and this is how you would actually use it. So this set timeout function, I just pass it a function and an integer, and it will call the function after 1 second. And then I can use this timer ID to call clear timeout. Now, if I would pass something else to clear timeout, for example, a string, then I will just get a compile error again saying, well, this should be a timer ID and not a string. So the examples so far were all of using Reason in a JavaScript context. But I think the cool thing is that Reason is really a general purpose language. So Reason started in the front end, and I think that's also where it's most popular. But they're now also working on making Reason a really good experience for native development, so for backend work. And there are several initiatives ongoing. So Reason Native is, I think, the official initiative to bring Reason to the backend. And they have SE, I think is how you call it, which is sort of a build system on top of Reason and OCaml. And it produces native code, and you can use OCaml libraries. And it's very much the same as using Reason in the front end, where you can utilize the whole JavaScript ecosystem. And with Reason Native, you can utilize the whole OCaml ecosystem. And you can actually share code between front end and back end, because all code you write in Reason, you can compile both to JavaScript and to native OCaml. There's also a pretty popular project called BS React Native, and these are bindings to React Native. So then you can use Reason to write React Native apps. And I think what's cool about this is that currently they are just binding to the JavaScript implementation of React Native, but they have plans to directly bind to the native parts of React Native. So you wouldn't even need the whole JavaScript VM running inside your mobile app. And that's something they are planning to do as a complete backwards compatible increment to BS React Native. So the code you write will still be the same, except that it will not go via JavaScript, but immediately use Reason Native to bind to the native Swift and Java code. So that's I think really cool. And then the last initiative, and there are more I think, but this is one I am aware of, is Reverie. And that's sort of like Flutter in the sense that you can use it to build native desktop apps. And there you can use React to write native desktop apps. So they provide widgets to, for example, render a list view, and it will render, I think in OpenGL or something, it can render a list view. So there you can use Reason to write actual native desktop applications that don't use a web view, but actually produce natively drawn UI widgets. But that's very young, but I think it's really, really something that could be very nice. So then I have a bunch of more code examples of some random nice features. So Reason also has a pipe operator. It has two pipe operators, which I think is a little bit confusing. But I'll explain in a minute why they have two. So the one is called the pipe first operator, and it works very much as in Elixir, for example, meaning that list.map is actually a function that takes two arguments, a list and a function that will map over the list. And you can write it instead of passing the arguments in a normal way, like first argument, second argument, you can create these pipelines where in this case 1, 2, 3 will automatically be passed as the first argument to list.map. And then the result of that will automatically be passed to the result of list.keep. And so this is called the pipe first operator. So it means that whatever is on the left will be provided as the first argument to the function you're calling. And then there's also the pipe last operator, which is written like this. And it's exactly the same, except that it will put the argument on the last position. And the reason they have this split is that in OCaml, I think the default way of writing functions is to always put the, in this case, list or array as the last position. Whereas in Reason, I'm not sure why, but they've chosen to design all APIs the other way around, to put them in the first argument. So this is a bit like here you can see that it's built on top of an existing language, and they made the choice to deviate a bit from the default OCaml approach. And again, I'm not sure why this is, but yeah, that's why we have two pipe operators. Yeah, one other nice thing is that with the pipe first operator, I think it's actually a little bit more powerful than the pipe last operator, because you can still make this, put the input value on another argument. So by default, it will put it on the first place, but you could also write comma and then underscore, and then it would put the input value on the place of the underscore. So with the pipe first operator, you can actually choose where it would put the argument. Yeah. So I think in Reason code, people typically use the pipe first operator only, and then this operator is usually only used if you interface with some OCaml code. Something else I think that is really nice, and every language should have it, is the fact that null doesn't exist. So null or nil or undefined is just not a concept. And the alternative is to use a type called option. An option has two variants. There's none and there is some. And with that, you can express in the type system that something may or may not be present. And this is so powerful, this prevents a whole class of bugs, because you are always forced, if something can be absent, you are always forced to deal with it. So for example, here I've defined two variables. X is sum 5, so this does have a value of 5, and y is none. And if I then define this function show number, which takes one argument, then it can either be none or sum, and you have to deal with this. And again, here I'm using pattern matching, so I can pattern match on the fact that this can be sum, and then in this case n will be an integer, and then you can directly use that integer. So if we would call show number with none, then it would return none, nope, nothing. And if we do show number with sum 1, then this branch will match. What's maybe a little bit confusing, I now realize, is that I haven't written the type definition again here. But the type of this function is a function that takes an option with an int inside of it, and it returns nothing in this case, because js.log returns nothing. But here you encode in the type system that the argument is something that can or could not be present. Yeah, that's really powerful. Yeah, another way to work with options is you can map over options. So this builds actually on the previous example. So x here is sum 5, and then you can use option map to basically execute the function here on the left, but only if the value is something. So if you would now pass nothing to this function, nothing will happen, because mapping over a none does nothing, because there is nothing to map over. But mapping over sum 5 will actually invoke this function, because then you have something to map over. So this way you can really, you can create pipelines using the pipe operator that will only execute functions if there's something inside of your option. So then you have the type safety that guarantees that you handle the options, and then you have some tooling around it to really make it convenient to work with functions that may or may not return a value. This is an example of how you can do JSON encoding, again type safe in Reason. This is just a library, but I think it's a nice example of how you can design APIs in Reason. Basically, these are two functions which take the person struct record that we saw before, and this function produces JSON based on that record, and this function parses the JSON and decodes it into an actual person record. So the encoding part is not that interesting, because this just takes a function, and then using this syntax you produce a JavaScript object with a name property and an age property. But the decoding is more interesting, because in this case, because we define that this return value should actually be a person, then the compiler will again help you to parse your JSON in such a way that it actually can produce a valid person object. So if we would omit this age line, then we would get a compile error because the return value cannot actually be a person. And also if we here would specify that name, I don't know, would be an integer, then again, that would be a compile error because name is not an integer but a string. So yeah, this is really, I think, a cool way to see how you can use the types to get the computer to help you more in writing correct code. And that's, I think, the general theme in Reason is use the compiler to have more confidence that your code is correct.
With the JSON.d code with the curly braces, does that mean that everything within the curly braces uses that JSON.d code? Something like that?
Yeah.
So syntactic sugar for scoping.
Yes. So over here, if you do JSON.encode and then a curly brace, parentheses, then all the functions you call within that are indeed in the scope of this JSON encode module. So you could also say JSON.encode.object, but in this way you can actually chain, because object and string and int, these are all functions on the JSON encode module. So that's indeed sort of syntactic sugar to work with modules and nested modules. And this is the same actually, but then it returns a record.
About the JSON decoding, what if the server sends a different kind of JSON? I would expect a type saying either I get the person back or give me back some kind of error.
Yeah, that's a good question. So basically this is the definition, and what's actually missing is there needs to be another JSON.parse after this, and there you can choose that the default parse will return an option of person, or you can have it throw an exception if you want to be adventurous. But indeed, so this can always fail, right? So this helps you write the correct JSON decoder, but at runtime you still might get a name field that is not actually a string. So in that case, the JSON parsing will fail at runtime. But yeah, that's nothing you can prevent because the input is just dynamic. But then again, the type system forces you to deal with the fact that if you actually call JSON.parse with this, that you need to deal with the fact that it might fail, because it doesn't return a person, but it will return an option of person. So why would you use Reason? I think if you like functional programming, then Reason is a really nice way to do it. It's a very powerful language. If you read the Reason documentation, then actually it might not seem that way. At least when I was reading the Reason documentation for the first time, I thought, well, this is nice. I like type safety. It's a nice language. But then if you start reading the OCaml documentation, then you see that there is a real wealth of features in OCaml that you can all use. And I think Reason is really a nice language to practice functional programming. I think this is also an important point. You really do need to like static type systems, because Reason has a really, really good static type system. But if you've never used a static type system, then it's really something you need to get used to. And I think in most cases, the Reason type system is so good that you can express almost anything. But there are always these edge cases where you need to perhaps write your code a little bit differently to make it fit in the type system. So that's something you need to be open to. Also, if you don't like runtime errors, then Reason is great, because it prevents almost all runtime errors. Of course, in situations like I just showed with the JSON parsing, where you have external data, then you cannot prevent runtime errors. Well, actually, sort of you can, because it doesn't have to be an exception. It can be just something the type system will guide you to handling that error. So in that case, it will not even be a type runtime error. So if you don't like runtime errors, then Reason is great, can help you achieve that. At this point, if you want to adopt Reason, then you should not mind being an early adopter, because Reason, like I said, is quite young, and also the ecosystem is quite small still. So if you're using Reason, then you are really on the cutting edge, and in my experience, everything works quite nicely. But you do see that, for example, all the libraries, they are changing quite a lot, because it is still pretty immature. This last part I think is also important. If you learn Reason, then you can apply it in many different use cases. So you don't learn it to just work with React in a type system. But if you learn Reason, you can use it for writing React code in the front end, but you can also use it to write backend code. And in general, if you learn Reason, you learn a lot about OCaml without even noticing it. But then you can actually start using all the stuff that's in OCaml as well. So that's a really nice bonus, I think. Now, there are also some rough spots. Like I said, the community is quite small, but it is very welcoming. There's a chat, Discord chat for Reason that you can ask any question, and the people there are really friendly. But yeah, if you compare it to something like JavaScript, then of course the community is really tiny. The documentation, that's a little bit of a problem, I think. It's spread in multiple places, and that is because Reason is built on OCaml. In the Reason documentation, they don't document things that they inherit from OCaml. So it means that oftentimes, if you really want to get the most out of it, you need to both read the Reason documentation and also the BuckleScript documentation and also the OCaml guides. Because BuckleScript is also a fork of OCaml, which is, again, has the same philosophy that they don't document stuff they get from OCaml. So you need to really look in three places to find all the documentation. And as a newcomer, that can be a bit confusing. It is something you can get used to, but yeah, that's definitely a rough spot. Third point that I quite dislike, there's no clear roadmap or commitments. So like I said, the project is really driven by Facebook, and they don't really make a lot of public statements about, what is their vision or what is the roadmap. So they do, put out some random messages on their Discord, but there doesn't seem to be a real good public roadmap. And also they are not very clear about which community contributions they take, because they do take them, but it seems to be that most of the development is really done by Facebook. So that's a bit of a concern. And that's also the next point. So you're really dependent on Facebook. I think if today Facebook would stop, then probably Reason would stop as well. So it's not that much of a community project that it could continue on its own. Hopefully, if it grows, then in the future it will become a real, true community project. But I think for now it's really dependent on Facebook still. Then next point is also quite a concern, I think. So that's incorrect, not Reason, but BuckleScript is forked from OCaml. So it means that OCaml has progressed, but those progressions haven't made it into Reason yet. And they are working on upgrading BuckleScript, but since it is a fork, it will always remain this way. They will also always lag behind OCaml. And it doesn't have to be a downside, but I think it means that it's a pretty big investment every time to keep up to date with OCaml. And I think this could potentially mean that, so now they are still updating to the newest versions of OCaml, but I think if Reason gets really popular, then it might mean that they will just leave behind OCaml and start their own ecosystem. I'm not sure if that will happen, but that could be one outcome. And then you get into this strange situation where OCaml code is not necessarily compatible with Reason. So that's a bit of a concern. And then the last part is writing these bindings, or more specifically, interacting with DOM can be a bit painful. And interacting with DOM especially can be painful because all the native DOM APIs in the browser, they are really built on dynamic typing. Every object and every attribute can have a different value, and you can write bindings for it, but that is really a bit painful. All in all, if you're working with React, you don't really have to operate on the DOM itself that often. So if you're writing React, then you don't notice this in most cases, but it's something that I found a bit difficult when working with Reason. Lastly, I would like to compare Reason to Elm. So before I picked up Reason, I started learning Elm. And eventually I switched from Elm to Reason. And so I have a bit of a perspective of how Elm and Reason compare. I think that the Elm syntax is a bit more elegant. So the Reason syntax, it's a mix between OCaml and JavaScript. And they've done that on purpose because they want the Reason to be approachable for JavaScript developers. But I think the end result is okay, but not as elegant as Elm. actually, you can choose to write native OCaml syntax as well. So we can mix and match Reason and Elm and OCaml syntax. I'm not sure if that's a great thing if you have one project with two different syntaxes, but yeah, you can choose to write native OCaml syntax as well, which resembles Elm quite a lot, actually. And then I think what's very telling is that I would say that Elm is like Apple. As in Elm, if you choose Elm, you need to write all your code in Elm. It's very difficult to interface from Elm to JavaScript. They have a few ways to do it, but it's very, very limited. Whereas in Reason, the vision is that, well, you write all your code in Reason, but you can still use the entirety of the JavaScript ecosystem. And I think that's much more practical way to do it. So I'm here making the analogy between Apple and Android. So in Android, you can also do anything you like, whereas Apple always, has these walled gardens. You can only do what Apple wants you to do. And I think Elm is very similar in that regard. Then also, I think what's a huge benefit is that if you learn Elm, then you can only use it to write Elm code. Whereas if you learn Reason, then it's really a general purpose language. So you can start using it in the front end, and you can take that knowledge and apply it in other scenarios as well. So I think, to me, investing in Reason knowledge makes more sense or has a bigger payoff than investing in Elm. Just because you can apply it much more broadly. And then lastly, if you would want to pick up Reason yourself, then these are some resources I can recommend you. The first two are sort of no-brainers. These are just ReasonML and the BuckleScript documentation. Then the third is a really nice read if you are going to work with Reason. It documents a lot of Reason design patterns, the more advanced stuff. So that's highly recommended to read. This is the online version of the OCaml book. Because like I said, if you read the Reason documentation, then you only get half of the picture. And if you start reading the OCaml book, then you can learn a lot of stuff that you can also apply in Reason. So I think all of the more complex or more advanced stuff that I've used in Reason, I all got from the OCaml book. So that's really highly recommended to read. Then this, like I said, so there is a Discord channel for Reason. So if you have any questions about Reason, this is the place to go. So there are, I think, about 300 to 500 people online almost all the time. And they are really helpful in helping you answer all sorts of questions. Can be anything like, hey, I'm having this compiler error and I don't understand it. And the people over there will really help you. This is a cheat sheet to writing FFI, so the debindings. This is really useful. There are a lot of examples, like if you want to bind to the default export of a JavaScript module, this is how you do it. It's very concrete and very useful. And then lastly, if you're into podcasts, then the Reason Town podcast is really recommended. They don't have that many episodes. I think they do once a month or something, but they regularly give updates on what's happening in Reason development. And also, for example, they interviewed Jordan Walkie to share the story of how Reason began. So there's some nice historic content there as well. And that's all I have. Are there any questions?